All right, let's start then. Well, that's great. We have how many people today? 10 people. Thanks everyone for the second session of the Protocol Forum. Our last recording is not live yet, but managed to organize our wiki page where we will store our technical notes, including the one that we discussed last time. So we'll be in the about deposits. And there's also some section about the custom token already setting up. But in the future, all our meetings will, the output was basically a recording on Odyssey and YouTube paths, and also the technical notes will be writing more and more here, so the protocol is more communicatable, let's say. That's one of the purpose to have this continued series. So today our topic is C777. I just started with some background, and then I'll hand over to Didi, who will give some overview of C777 history and how Superfluid sees it in the future. So C777 as a standard has existed for a while. Didi will go through that for us. And Supertoken is one of the one in the in DeFi, I guess, enabled it by default with all the with all the braveness, I would say, due to its several stories around it. So Supertoken is C777, in case you didn't know. So it allows you to send tokens to contract, and the contract can have a callback, so similar to the Super app you might be familiar with already, to execute the same some action in the same transaction, right? So that's the purpose of it. And it has less complication than Super app because everything happens in the same transaction and either fail or succeed. But Super app has a jail system due to its some of the async aspects. So yeah, I mean, if you're not familiar with the feature yet, have a look, and after this call especially, think about it. One of the project before I would want to mention is called wow, how's it called actually? Project name, the ERC777 swap or something like that. So you send the token to a contract, and the contract will unwrap it and automatically swap against maybe Uniswap, using Uniswap or using HoneySwap or whichever the chain we're talking about here. So it's like one transaction experience, and because you can attach user data like the Super app callbacks, the user data, you can encode certain behavior, right? So that means you can do one do a swap in one transaction without doing approval, which is the magic here. Because if you use the Uniswap or other things, right, that also always is ERC20 approval in a way in the first place. And with ERC777, a lot of things go away. But that's just one use case. There are a lot of use cases you can enable. Think of Super app, right? Super app enables a lot of use cases, and 777 is actually the predecessor of this in general. So I'll leave to Didi to continue the history about it, and then we can then do a little bit brainstorming and discussion around this. And I've also sourcing your view regarding should we do a little bit of variety in the 777 support due to the security issues that posed potentially by it, or should we stick to the standard? So go ahead, Didi.
Yeah. So before I tell anything about it, I thought I wanted to get just a quick feedback. So before influencing you with information, I just wanted to get a sense. So for example, who already used the ERC777 interface? Okay, Joshua. And what do you think is 777 a useful improvement over ERC20? And any opinions there?
Yeah, I mean, of course, the avoiding the pattern of the approve transfer from is really nice. Obviously, you can just run it in one transaction. And same thing with the user data, right? Like I've used that to like encode other logic, right? Like for example, if you wanted to send a transfer and then let's say the receiver is a contract that wants to create a stream, you can just encode the flow rate right there, which I think is really, really cool. I think Toga actually does a similar thing with like the exit rate and stuff like that too. So
yeah,
cool stuff.
Okay, then let me try to screen share. Sorry, my Zoom crashed. Okay, I will try once again. If that doesn't work, I will ask Meow to share the screen.
They all make faces.
What the fuck?
TV just got bugged.
You hear me?
Yeah.
Okay, that's funny. I don't find the application anywhere.
There's a little window in one of your workspace.
I know, usually there is, but it's what the fuck.
We don't do beeping, so feel free to skip that.
Meow, can you in the meantime open this document?
Yeah, sure.
Icon. It's incredible.
No worries. If you can teach me how to close a pane. This one. I'll just click it. How do I close this left pane? Never mind. All right.
Okay. So this is a nice visualization I found in a master thesis around about 777, which is about the evolution of token standards. There's actually many more. There were many more proposals than I knew of. So I listed 3 of them with a bit more detail. Those which, when I was around, which I noticed, which seemed relevant to me. So I started digging into Ethereum in 16. So ERC20 already existed then, was already kind of established, and the others came later. But even ERC20, so now if you open the link to the EIP, I think one characteristic of ERC20 is because it was so early, it was quite minimal, primitive, but I think to some degree it was also kind of not very strictly defined. So, for example, it doesn't really say that decimals can't change, stuff like that. So it allows all kind of things by not explicitly forbidding them, because I think that's what a standard or language usually is about restricting, and it's not very restrictive. So yeah, people started using it, and as you may know, there are also many early contracts which used it in not really standard compliant ways, like not returning a bool, stuff like that. And so let's switch to the next one. That's also linked. The next, I think, relevant one was so first the author named it ERC23. Not sure for which reason. I think it's related to Ethereum Classic, which was still potentially a thing back then. And but then it became 223 because of the issue number. So I followed this back then, and yesterday I went through most of the comments again, because it's pretty interesting to see the conversation. And this got some pretty I would say, involvement of the core community. Guys like Alexander Sand were involved, and Nick Johnson of ENS. And for a while, it seemed that 223 may become kind of a new polished version of the Ethereum token standard. So there was kind of consensus that ERC20 was kind of a first and fast shot and had significant flaws. So the main motivation of the author here was that he was very concerned about all the funds being lost because accidentally sent either 0, accidentally sent to the token contract itself, all this stuff. I think I also linked an incident where just a few days ago, there again was an example where somebody sent, I don't know, 500,000 or so to the token contract. That was actually pretty interesting because my first reaction was, yeah, I mean, really that still happens to people with current tooling. But then actually there was a screenshot in a Twitter comment where the guy says what happened, and actually it's not so kind of understandable. So what the guy did is he sent ETH to the VEF contract for wrapping, and then I don't know, I work with it, etc. And then he assumed, okay, that in order to unwrap it, he just reverts, and he sent the VEF to the contract again, expected it to unwrap. But yeah, that way he burned it, and this was an early ERC20 contract, which allowed everything, which allowed to send the tokens to the contract. And yeah, so this stuff is still happening today. And this was basically the main aim of ERC 223. So the discussion evolved over basically all of 2017. And it seems to me that in the initial months, there was the perception was quite positive, and there seemed to be a chance for consensus forming, and there were different projects already implementing the draft proposal, but then the draft kept changing, and then increasingly it became clear that it is not as backwards compatible with ERC20 as it was, as the author supposed it would be, because what he also did is he redefined the transfer function to require that a receiving contract can signal that it can receive the token. So he basically added a hook to the transfer function and said in the standard, if the receiver is a contract, then it needs to implement a given hook, or there needs to be a mechanism by which it can tell, yeah, it's safe to send to me. But the problem is that way it wasn't really possible to have a token contract which is at the same time really compatible with ERC20 or not. I mean, there was a lot of discussion if it is compatible or not. So he said it is. It's just that it's how ERC20 should actually work. That was his point. While others said, well, but that's not what everybody expects. There's many use cases, for example, multi-sigs, where people expect that the contract can receive the tokens, and that would not work if a contract tries to be combined to both. So the end result was that it didn't really go anywhere. And by the end of the year, there was also by some of the core people this the opinion was, okay, it doesn't make sense to have kind of a band-aid here, and it's better to do a new token standard which considers not just that specific aspect, but which addresses more of the flaws and weaknesses of ERC20. And one of the guys who was also involved in this discussion then proposed, okay, let's first switch briefly to the 677. The 677 is, I think, an example for a nice EIP which does just one specific thing. So it said we want the possibility to have a hook with the transfer, and so they added transfer and call and definition of the interface for their contract, how to handle the hook, and that was it. It was never finalized, but I think that was mainly because they didn't really bother to that. It was not really contentious or something. And this is actually used for a long time already by the POA token bridge. I don't know of other uses, but I know that there it's used already for a while. So this, I think this was, this was proposed mid-17, and I think this was about having a formal EIP for something they already implemented. And then towards the end of 2017, there was the proposal of the 777. I think this was an Aragon guy. So they were also involved in the discussion around 223 before. And this was actually a pretty comprehensive proposal, going considerably beyond the functionality of ERC20 and also what 223 proposed. And the different aspects it touched was it wanted to be kind of a version 2 even of ERC20. There was in the comments there was a proposal to name it Ethereum token standard version 2. It wanted to be backwards compatible. It wanted to cover the full life cycle, for example, also defining methods and events for minting and burning. They wanted to have data fields so that arbitrary user data, user data, they didn't call it user data, arbitrary data can be passed along. And the hooks were pretty central concept. And I think one of the aspects which made the finalization and adoption probably a bit tricky was that they specified it to rely on ERC 1820. So ERC 1820. So at the time of writing, it was ERC 820, but I think there was an issue when 35 came along and they had to update, they had to change something, so it became 1820. And ERC 165, which is about interface detection. And I think the reason, as I understood, the reason why they wanted this and not something simpler which can be integrated in the contract is that they wanted the ability for EOAs to register hooks, and that is and that's done by, can be done by having a registry where they say, okay, if for my address this or this is invoked, then please execute this hook. And this would not have been possible without this external registry. So this, what I have here in bold, is copied from the standard itself. So this is the part which is relevant for our topic of today. So while they say and claim it's fully backwards compatible to ERC20 and not in the questionable way like ERC 223 would have been, I would claim that what they defined here could still be, one could still argue that this means it's not fully backwards compatible because this changes the behavior. So what they're saying is that if a 777 token implements the ERC20 interface, which is optional, by the way, can even change during its lifetime. So they also described how if during the lifetime of the 777, the ERC20 interface is switched on and off, that which events it has to emit, or no, I'm not sure about the events, but it has to register this in the registry in 1820. It needs to register if it implements ERC20 or not, and this can change during the lifetime. And here they say that if the ERC20 interface is enabled, then the ERC20 transfers also must, and they specifically say must, invoke the hooks. However, in a non-blocking way. So if, for example, if there is none, it's not that the transaction should fail like in 223, but it should work anyway. But if there is one, it needs to be executed. That's what's specified here. So it was also discussed for a year. Initially, it seemed to make good progress, but then during the second half of the year, so this is now 2018, it slowed down a bit, and at some point authors became a bit unresponsive. I guess that was also related to there being crypto winter, and I think a lot of teams projects struggled with resources. But then in early 2019, it got a bit steam again, and they managed to finalize this dependency, which was 820 and then 1820. And as soon as that was ready, the standard was declared final. So it really made it to the final stage. And there was also immediately an OpenZeppelin implementation available. So then it became interesting. So just a few weeks later, there was. So I think first there was an audit by I think by consensus, and this was an audit of Uniswap v1, and they noted that there's an assumption that transfers don't allow re-entrances, so that transfer doesn't execute any code which could create re-entrancy, and it explicitly mentioned ERC777 tokens as an example for how that could happen. And I guess that based on reading that, somebody at OpenZeppelin wrote a proof of concept for such an exploit and published it. So this is now mid-2019, shortly after the finalization. And then for about a year, not much happened. I think there were a few projects publishing ERC777 tokens. But then in short order, there were two major incidents. The first was Uniswap v1. So basically happening what the audit had warned against. There was, I think it was in-BTC pool, and with this so-called micro trading attacks, how the OpenZeppelin guy named it, they managed to drain several $100,000 worth of assets from that pool. And then there was a bigger one with some DeFi protocol where I think they lost basically all the funds. So these numbers so this is now mid-2020, I think, early or mid-2020. And I think back then even today this would be significant numbers, but back then even more. And yeah, Uniswap v2 protected against that by adding locks, and they also explicitly mentioned that in the white paper. And I think that this incident kind of killed the standard. So I think that's what made them be perceived as being unsafe. So this is a bit reminiscent of the DAO hack to me, which was a re-entrancy issue with ETH itself. In response to that, they changed. I think they changed the semantics of the sand, so with the minimal gas event, etc. And now there was this token standard which tried to emulate this ETH sand, which was already being perceived as dangerous back then. And I think that a lot of projects just don't want to think about this risk. So that's something I've seen in other places. For example, I remember there having read an audit of the BOA token bridge, where in the initial design they had a model where the rewards would be pushed to the post-star validators, and then the auditor said that's probably unsafe because stuff like there could be a receiver with a hook, or there could be, you don't really know how much gas, etc. So there was not really a concrete example for why it would not be safe. It was more this sentiment that something we've seen in the past could go wrong, and because of that they rewrote that logic and made it withdraw. So like with ERC20, where you have to approve and transfer from, they made them first the bookkeeping, and then anybody could withdraw. So what else? Yeah, I also noted here that what happened with Toga V1, I would say, was also kind of related. So it was not a re-entrancy issue. It had the locks protecting against re-entrancy, but it was an issue which was created because of the hook, and because I didn't consider all the possible ways this could work out with different gas events, etc. I mean, I think the overall conclusion is that hooks are very powerful, and there's clear advantages, but they're also tricky. And I would guess, I didn't really research that, but I would guess that there's many protocols out there which, unlike Uniswap V2 Plus, are not really safe when used with token contracts where transfers could cause re-entrancy. So I also managed to figure out finally the most relevant ERC777 tokens on mainnet, because Peter at LabDan recently wrote an indexer which indexes all the various tokens. And I took the data from that. And so this is now ordered by, I think it was actually, I ordered by minting events, and this is now ordered by the most holders. So the first one actually is, please give it a look. First one seems relevant with over 200,000 holders. However, it seems that was just an airdrop back when you could afford to do airdrops on mainnet, and it's not really a living token. Then the second one is, I think, is this MBTC. So this is the one which was involved in the Uniswap V1 incident. It's still relevant, still used. And the third one, interestingly, is also a BTC token. So somehow the BTC files seem to like 777. I didn't know this one, but also seems to be a used token.
Did he index the sand event? Was that he was looking for, or?
So this data is from the mint events. The sand event I also tried, but that seems to be buggy because it didn't find anything. That's something we need to check.
That's interesting. Oh no, sand event only triggered when you do actually .send. I mean, nobody uses sand function, right? That could mean easily.
Actually, that could be the reason. I didn't think about that. Yeah,
I think
right.
yeah. Okay. Yeah, continue. I think we'll mention that they're related to should we use send or just transfer.
Yeah.
Yeah. Okay.
So yeah, coming to the super token, I voiced the opinion in the team that I think even though it would violate the standard, I think we should change the super token logic such that ERC20 transfer does not invoke the hook. And yeah, and the reason for that is that I think it's a hazard, and I think it may backfire one day. And I see the risk that, of course, you can always say, well, yeah, it's your fault. You should have read the standard, etc. But I think that doesn't really help, because if it happens, I see a big chance that that it will harm the perception of the super token standard itself, the super token protocol itself. Because the thing is, we use hooks in different places. So even if we didn't implement 777, there would still be the hooks we have in the Superfluid specific functionality. But I think there it's not really a problem, because that's a new functionality, and somebody using it is supposed to first check what it's doing. The problem with ERC20 is, and that's something which was also discussed a lot in these standards, in the conversations around the standards, that if ERC20 is dominant and already widespread, then so you have a function name, function signature, and then people expect a certain behavior of it. And you cannot just, so I think, and if you less or more subtly redefine that behavior, that's also, I would even say a kind of rug pull the developer, kind of, if you change the semantics of something. And that's why I think that, so I think it was a mistake of them by requiring this, by making this a must. But it happened, and I think, so it seemed to me when reading the conversations that this was also done like this in the expectation that this would become the dominant standard anyway, and then people would know and be aware about that. But that actually didn't happen. There's, I think, not so many people knowing much about 777. A few of them really have used the 777 specific interface. So I think that's not a safe assumption to say, okay, if somebody sees that this is not just ERC20, but also 777, that they even know that it has this implication. I don't think that many people know this. Yeah. So that's basically the proposal to remove that, but then that creates the question, okay, what does that mean? Should we still say that it is that it's implementing 777, although it's not, although it's consciously violating a part of that standard? Should we somehow say it's a variation of like something like 777 plus, or I don't know, or even formally create an EIP where it's proposed to be a safer version? Or so that's basically the questions for today, and yeah, asking for opinions.
Okay. Yeah. Thanks. It's great. I think the only use case that we can definitively point out for the 777 standard in Superfluid ecosystem is Toga, right? And for the existing Toga v2, in order for people to become a pig, we can simply switch from UI that you do a send instead of transfer. That means your wallet. So if we enable this paradigm that we deviate from the 777, remove the possibility of triggering a callback while doing normal ERC20 transfer, that means you wouldn't be able to become a pig just by transferring Supertoken. Then you have to use our perhaps the Toga UI to do the transferring, which we'll call the ERC777.send as opposed to .transfer. Is that correct?
Yes.
All right. And did you do any like research regarding the wallets for .777, or is it kind of died out efforts?
I did not. I'm pretty sure there is none, except maybe IM token. So I didn't really check this, but I would guess that this IM BTC may be related to the IM token, and there's IM token wallet. So
right.
Maybe they have.
Connection. Yeah. Okay.
But I didn't check that now.
Hmm.
Actually, I wrote a very simple one. Basically, it's not a wallet; it's a dApp with just a mask for send, and in the background it uses 777 send. Because actually, at Lab 10 we also did 777 token, and I think in 18, so an internal token, and I didn't find any wallet or something which can use it, so I built a simple UI, but I'm not aware of any. No. So it seemed to have stalled. So there was initially quite some interest around this standard, but it was still in draft. But then came crypto winter and somehow was forgotten, it seems to me. So what I also didn't check is if there's adoption on any other chains and other EVM chains ecosystems. I can't exclude that, but I don't think so.
I think another thing relevant to mention here is the future native batch call support, right? So that also can make this whole need for the ERC777 specific use cases going away almost, if you could natively batch, right? So Superfluid way batch is not native, right? So it only works for super tokens, but EIP native batch, if it got enabled, if you could remind me which number is it? I have the notes, but I don't know where to find at the moment. So natively have the new transaction envelope, allows to do a batch transaction in a new type of the envelope transaction, and then most of the ERC777 use case wouldn't be almost necessary. Not sure about the super token paradigm. Probably we still need a callback system, but probably not. That's a longer term thinking stuff. But
well, most of the use cases, I'm not sure, because, for example, the operator design, that's, yeah, for example, what you can do there, you can define arbitrary constraints relying on arbitrary state somewhere. I think for that, well, actually, no, the operators you don't need for that. For that, you only need the hooks.
right.
Yeah, there's various aspects. I mean, one could argue that some of the functionality should be removed. One could argue that some things should be added. For example, what's not there is that you can execute something with signature. I think I linked something there. I saw that you commented on that in 2018. That, for example, could be useful. It's at the end, the one, yeah, the last character on this. No, here at the end of the page, bottom right, there's a link. This one, yeah.
Can't be.
And if you go to the comments, yeah. Yeah, I also found a comment of mine on 777, which I didn't remember. So.
Comment that? Okay.
Or was it another high wave?
you talk it out. I don't remember. What was I on? All right. Oh, actually, I want to mention one. Yeah, you can make the point. So yeah, 777 is more than the callback. We have been focusing on callback, but as a consequence of blindly following the standard in Supertoken implementation, or actually not blindly, because we actually used OpenZeppelin code base as a starting point, right? So they have operators and all those stuff implemented. So we kind of drag those in already.
Yeah.
But I guess for the relevance of this talk is, or discussion is, if we were to make a Supertoken standard natively, then we can pick and choose what are the things we think actually useful. I particularly have some problem with operator design, to be honest. I don't know how many infrastructural projects are actually using it in the first place, and is it a good idea? So do you have any insights on that in terms of operator usage?
No, but I couldn't, I could actually extend this indexer and also look for them. That may be a good idea. So yeah, that's something we could and should do to really, by looking at the events to check what's actually used, because if there's some functionality which nobody ever used, then maybe it's really better to drop it.
Yes, I'm kind of suggesting the approach that we don't blindly follow standard as Supertoken. We have added so much functionality that if the 777 as a standard itself is not going anywhere and just following as it is, doesn't seem to be a super useful approach. But we do need to review the operator thing to see if it's something we should continue to use.
And I think if we keep it, then maybe it would be good to extend it not just to the non-real-time functionality, but to the whole Supertoken functionality. I also think that should be a priority. Yeah, exactly. So I see some new people joining, Samuel, and well, we've seen you before, and Blackboy was here. He got bored and left. sorry about it. All right. Anyone has some thinking about this? Oh, that's Sam. I'm sorry. They changed the name.
I think.
Yeah, we had different Samuel before. I'm sorry about it. I thought you didn't open your video.
Yeah, welcome, Sam.
Welcome, Sam. Well, your face looks familiar. So
This has been fascinating, I guess. I've learned a lot about the whole token history.
It's like a OG become a historians. I call it Ethereum historian. You can write a book and sell it at some point.
Ethereum archaeologist, is that a thing already?
Well, I mean, Ethereum as a digital relic at some point, you'll be able to dig a lot of things out. I wouldn't be surprised. But anyway, so anyone has some thoughts, comments on this topic in general? We still have a lot of time left, so we can expand on things if we kind of exhausted things to talk about on the callback itself.
Is there anybody who thinks it's a bad idea to remove the hooks from the C20 transfer?
I'm kind of neutral on whether or not it should be removed, but I do remember looking into it and thinking it was weird because there were some cases where honestly I can't even remember what it is now. It's been a while, but I explicitly wanted the send and the user data there because I don't think transfer includes the user data. I'm pretty sure it's just the receive.
Actually, that's why in the Toga we specified that if there is no user data, that there is a default. Otherwise, this wouldn't have worked.
Right.
I was thinking, Didi, you said something right at the beginning of the call where with the Uniswap V1 attack, where these a lot of these DeFi protocols may break when actually interacting with 777 tokens because they just weren't designed for them. Is this something we are a little bit cautious about now, especially, I mean, this year you probably will beginning to see super tokens in many different DeFi protocols, I imagine, on L2s. And yeah, I think it wouldn't be good if there's a bunch of just free money lying around for people.
Yeah, I think we need to be careful with this. So I think that it wouldn't endanger the protocols themselves. Even in Uniswap V1, it was the specific pool which was a factor and not the protocol itself. But that's already bad enough, I would say. And I mean, okay, as we have seen, there's still 777 tokens being used on mainnet, and that means nothing catastrophic happened with all the protocols which came later, etc. But still, that's mainnet. Who knows? Maybe on other networks, the protocols which are deployed are not as well thought out or whatever. It just, I think for what it's worth, it's not worth taking the risk. That's my intuition.
I think the other angle is that we need to see what are the DeFi protocol actually natively support Supertoken. So if it gets getting more and more popular, which we expect, then better we kind of have a definitive solution to that. I think disabling that is a good one already. I don't think there's benefit in enabling for those protocol, and more uncertainty than benefit. So probably something that we should do fairly quick, and just plug that off and make all the super tokens kind of non-777 standard while still having the callback functionality.
Yeah. To be honest, I also don't think that anybody would complain even if we change that and don't explicitly mention it. I mean, yeah, if you look into the code, you see it uses it would use modified OpenZeppelin implementation, maybe somewhere in the docs or in the repo, we could mention it. But even if we still say it's 777 compliant, I mean, I don't know. The alternative is that we don't talk about 777 at all until we figure out how.
I mean, 777 inspired is probably an alternative way of saying it. We're inspired by 777 in many ways, right? The callback, and we're inspired by ERC-20 also. I mean, we're not necessarily compatible. Well, it's a standard that doesn't really have a lot of constraints, so we're kind of compatible for sure. But 777 has more constraint, and we are gonna delete something there, right? So I think 777 inspired is a way I think we could put it without being not accurate.
I mean, there are. I also favor an approach more like, to say, more of a next generation kind of a new standard. I mean, there's a diagram at the top of this where you mentioned ERC quadruple 1 or whatever it is. So there are, I don't know anything about these. So I mean, there are clearly attempts to approve on 777. Do you know anything about this standard or some of these other ones kind of lower down?
No, I saw it the first time, and this is actually a snapshot from. Yeah, how far does it go? Mid what is it? Mid 18. So this is from this. I think it was a master thesis of a guy who co-developed 777. And so I'm pretty sure that there's a lot more proposals which came later, which are not included here.
I think 1155 is the one that missing from this picture.
Yeah, 1155, as far as I know, is what. So as far as I see it, there's currently 3 relevant standards, and that's ERC-20, 721, and 1155. Those seem to be the 3 really relevant standards at the moment. And from others, I think one can draw inspiration, but I'm not convinced that it makes sense to plain implement them. The thing is with, it's also a lot about adoption and network effects, because Supertoken is something new anyway. And if it's new anyway, then I think what's important is to keep ERC-20 compatibility, which thanks to the loose definition of ERC-20 is possible. And other than that, I think we are pretty much free. That I don't think there's much advantage to saying we are strictly 777 or whatever else compliant. Yeah, as you said, now it probably makes sense to say it's inspired for those who actually are aware of 777, and I guess there's people out there who think it's a pity that it didn't catch on, and we'll be happy about that. And what's also interesting in these conversations, there was also sometimes the topic about, so in the conversation about 777, there were some who said, this is somehow too big. This should be modularized into multiple EIPs. And others who said, no, that should not be the case. And that's something I also thought about when it comes to Supertoken. If it would be better to have one standard which includes everything, all the functionality, or if we could somehow modularize it also in order to have lower entry barrier for a project like a wallet or a dApp to say, I want to add support. Because maybe if it's a huge standard like 777, maybe that's kind of intimidating and discourages integration. So I think it could make sense to try to modularize it, even if it's in one standard, to define kind of levels of integration. So how comprehensive the support or the integration is. Because the cool thing is that basic Supertoken support you already have with ERC20. So even if it's about a real-time balance, I think that most wallets actually do show the live balance, at least on a block level, because they do update the balance for listed tokens every block, last I checked. So that's already an implicit kind of minimal support for Supertokens. And I think it would be cool if we define, I don't know, 2 or 3 additional levels of support where, for example, the next could be being able to create a stream, etc. But this is already diverging a bit from the topic, maybe.
Sorry, Joshua, go ahead.
Yeah, so just briefly on the topic of like the send and transfer thing. So obviously, like, you know, send is a way, a dot send is a way to kind of negate the need for like the approved transfer from pattern. But of course, like there are still people that you know rely on the approved transfer from pattern, right? For, you know, they have like obviously, like if they have an immutable contract, right, they can't really upgrade that if it's not explicitly upgradable. But I think there's definitely a use case for like being able to use an approved permit, right? Like you've seen this a few places where basically you can generate the signature for an approval permit off chain, and then you can run it all in the same transaction. I think actually OpenZeppelin has, I think it's just called ERC20 permit, but you know, basically it's just a way to run that approval. So right now with the current Supertoken implementation, like it's kind of possible in like a really hacky way that's just not really practical. And so yeah.
Sorry, just interrupt on that. We are implemented a self transfer from and self approve for, and so that you could implement in the custom logic level permit. But actually, we're also adding permit, so you don't really need to do that. But those new self functions could enable new custom token feature, right? So in the very beginning of the call, I mentioned that you could have a look at a certain building base, but in our wiki. So we're gonna have a is it updated? Probably not. It's so the so-called self-call pattern. And how do you use that to take advantage of that to become kind of building block for the custom features, which Joshua, you are taking on to have a wizard, right? So that's the building blocks for you. So we have a self-mint, self-burn, self-approve, and self-transfer from. Streaming mint and streaming burn is streaming mint is something that needs a bit more than just a self pattern. So that's kind of thing that would we would likely take on in the future. But just from this, we can already build a bunch of custom features, right? So to your point about approve and the self approve is your friend. actually self-approved for, I think, the function.
Cool. Yeah, I mean, I was basically just going to advocate for that. I'd heard mention of it here and there, but I didn't know if it was already in the pipeline. But you mentioned that you might be adding like just native like permit support. So like, is that just going to be like really just implementing that ERC20 permit function?
Would be, yeah. I mean, do you have opinion? We could add it to the, no, the thing is we could always add to the Supertoken logic. Currently, the contract size is not reaching limit yet, so we don't need to break it down so far. But I just want to briefly mention, almost on a tangent, the plan of moving to a token-centric interface, right? So currently, one of the biggest developer-oriented UX issue is that you need to do the core agreement, which is quite exotic pattern for a lot of the users, right? So Sam did a CFA V1 library. If you haven't checked it out, right? So it's a library approach to wrap all of those into a easier to use interface. But generally, for the future version upgrades of the Supertoken, we're moving to a token-centric. So every operation has become part of the token interface, right? So internally, we'll rewire how the core is made. But that way, basically, we're talking about cutting section of the feature, right? So actually, I just do a quick jump. Like in 2 weeks, we're gonna philosophizing a little bit more about what is superfluid concept, right? So for the token-centric interface, you can consider the ERC20 is one section of the feature. So it's about the called transferable balances. And then you have the CFA section of the interfaces, which is create flow, delete flow, update flow, this kind of thing. Then you have a section of interfaces about IDA, right? So if we can call create flow, create index, this kind of thing, all through the token interface, that would be more kind of common, probably feels more usual for most of the developer, right? So that's called a token-centric interface. The reason I want to mention that is a permit could be considered a part of the transferable balance agreement, which is ERC20 basically, part of that. And but at the same time, permit is not necessarily a good standard in many regards. So to be included in the Supertoken or not, it's up to us to think about more, because you can always add that in the custom token if you really miss that. But there are better way of doing it, namely meta transaction, which is a more general implementation, right? So we'll see about it. But the bottom line is with the self-approve, you could implement that in the custom logic at least. To be included in the Supertoken or not, we can discuss more in the future.
Sorry, just wanted to go back to 777 and make a couple of comments. First of all, I think we can remove the hooks from transfer, but I think there's a very good reason to keep send. Like I think send is a much better way of sending funds because you can add metadata, so you can actually use it for payments, right? Like there's a reason ERC20s aren't used for payments nowadays. And the fact that exchanges have to create a separate account for every single deposit you make, which creates huge gas costs for everyone. Like there are reasons why send is significantly better than transfer. So I would keep it there. The problems I see with splitting completely send and transfer are on the derived functions. So if you look at burn, if you look at upgrade, downgrade, right, or mint, burn, whatever you want to call them, should those have hooks? Should there be twice as many with hooks and without hooks? Like that's where things get a bit tricky, and I think we haven't talked about that, so worth addressing.
Yeah. So the burn is actually part of 777 standard, so that's actually considered mint perhaps, not burn. That's funny enough, right? It's the detail about the standard. Burn is part of, mint is not. Mint function is not, but mint event is. It's very confusing, but it's a bit they're actually quite clear in their mind when they design the standard. So Mint is not part of standard, but Burn is. You can think more about it why. But yeah, so Burn is 777. To your question, I would say that yes, we will have the callback part of it. Because if you use Burn, you should be aware that there is callback. That's not the case for the transfer.
Or we remove burn too, just leave the event and leave it to the implementation.
Burn is not exposed in Supertoken per se. I mean, Burn is in our implementation. Burn is an internal function that is called by either downgrade process or either by the custom token logic. Right? You can't just burn it. Right? So it's either a custom token which it has its own burn logic, or either it's ERC20 wrapper. Burn basically means downgrade. The question is, should we remove the callback ability for the downgrade? Actually, we had even use cases about downgrade and the callback, right? Or maybe more related to upgrade and the callback. Can't remember, but those are actually interesting. Upgrade and callback, yeah, that's more.
Yeah, that was a problem we discussed once, because it basically means you can't use upgrade to send funds to a Gnosis safe, for example, because it doesn't have the 1820 hook in it, right? So yeah, I mean, it's fairly limiting. That said, it's hard to judge based on usage because I don't think anybody's using it, right? So if we think there's merits in both, then there's merits in having both mint and mint with callback, right? So yeah, I don't have a strong opinion here. I just wanted to mention that this is a problem we have to address as well.
Actually, from the upgrade about the main function, we kind of already deviate from the implementation standard of 777, which is Open Zeppelin. I haven't read in that level that if the mint should call callback or not. Is it part of the standard? As I said, there's no mint function even here, so I guess it's not unspecified behavior.
If I had to choose, I would say no callback, because I think I think it's way too exotic, so nobody's going to use the callback anyway. So I think we might as well just remove it.
Yeah, or since the user data is present anyway, so we can use user data as a kind of hint should the callback be called or not, right? So by default, never called. If you put some data, it's going to try to call the callback and revert if no, not valid. Yeah.
Also, I think so. Like the multi-mint implementation that I've put together already, it does it all from within the Supertoken contract, right? So like the Supertoken itself is the publisher of the IDA, right? And then anytime it mints, it distributes. But originally, I was thinking like instead of it being on the Supertoken, you could basically have like a receiver contract, right? So you have like the Supertoken, which mints to a receiver, and then that receiver splits it with an IDA. And I don't think that would be possible without a mint. Well, no, because you would mint and then no, because you're minting directly to the contract. So you wouldn't be able to take advantage of any kind of callback with that kind of thing.
But if you are doing a custom contract logic, you don't necessarily want to call back at all, right? Because you're composing all operations together. So you can just mint to there and call the correct function. If that contract doesn't mind potential state async, right? So the callback is about synchronizing the states. So it doesn't allow case that you send a token, but you don't complete the state transition, and then you have token locked there, but you haven't finished the operation. The callback prevents that. But if that's not a problem, then you can just compose a right sequence of operation in the custom token itself. I guess depends on use case. Actually, I want to roll back and mention something that, my opinion about ERC20, why it is a loose, it's being a very loose standard, and how we ended up here. It's actually, I would say it's well, we had a fluke about it in a way that if it was not like on Solana and like on Cardano, this kind of system, we'll end up token system that are not very superfluid design friendly. So, for example, we're looking into Solana POC or Cardano POC, right? One of the first problems is that they have natively implemented a token standard, which is very rigid, right? So you issue a token in the layer 1 almost. Right? It's not exactly like that, but something like that. And why ERC20 is nothing to do with the chain itself. You just conform to a bunch of interfaces and you are supported by the wallet, which is a accidental design, maybe, but maybe the one designed it had something thought out. I don't know. It's not very clear from the spec. But I think as a fluke, as an entire ecosystem of Ethereum, it kind of benefited from it, or at least for benefited the Superfluid. Otherwise, we would have a harder time to actually getting adoption, because then your token would be not even ERC20 compatible. None of the wallet we support. Imagine how tough that would be, right? So I think it's kind of fluke that we end up here. My feeling that it's kind of fluke that we end up here.
Yeah.
We still have some time. Should we open some new topics? Is token so boring?
So can we do we agree on everything?
Oh, come on. Don't push for agreement. So are we doing a vote now? No one has token yet.
We'll vote with our XP from Discord.
XPR.
Yeah, well then Joshua, you decide basically.
Yeah. So XP whale.
Yeah, not so different from ERC20 voting, I guess. But yeah, I mean, if we have some time, I'd like to briefly talk about the meta transactions. But obviously, if there's any more to discuss on this first, it can definitely wait.
Right. So yeah, we could. I mean, I don't know which direction you go, but we still have some time. But in terms of decision-wise, I think so. My proposal, I think everyone almost said similar thing. I think Joshua, you're kind of neutral. Is that we are gonna establish some sort of super token standard at some point, and that would pick and select which part of the existing standard that we are gonna go with. And we're definitely going to be ERC20 compatible, and will be ERC777 inspired. And we will also standardize the transferable balance, constant flow agreement, and instant distribution agreement, or perhaps even the general one instead of the just instant. So those will be a new token standard. We'll just pick and choose. So that's a proposal. And the specific way why we want to pick and choose is to disable the non-standard behavior of transfer, which the C777 broke it. So we just disable that and going forward. And we'll even enable that before we have standardization. That's my proposal. All right, good. We have the XP way of voted, so good to go. Fran, do you want to vote?
Actually,
okay, DDS. Okay, go ahead.
Maybe I'm the only one who has some ERC777 tokens, which are something different than super tokens.
Right.
So maybe if it's token votes,
okay, so yeah.
Vote by variety of tokens rather than number of tokens, right? I would vote for Joshua.
What does it mean?
Joshua for 2024, yeah?
Yeah.
Great. Which state or federal level?
Florida.
wait, Joshua, which state are you from actually?
So I'm from South Carolina, but I don't like to talk about that. Yeah, no, I'm down in Florida now.
Cool. All right. Okay, so Joshua, go ahead if you want to talk about the meta transaction. Wow. What's the yeah, go ahead.
Yeah, so For one, so I mean, as anybody that's dealt with these things already knows, the Biconomy contracts aren't verified, and it is incredibly difficult to get these things verified. I've tried doing it myself. I've tried forking their repo. It's a huge pain, and I think it would just be easier in terms of like you can get better stack traces, you know, whenever it's verified, right, with things like Tenderly. But that much aside, so I was looking at it, and I was talking with somebody else about this actually earlier today. So currently the way, you know, from a high level, it seems the way that you run these meta transactions through Biconomy is you create a batch call, you basically wrap that in their struct, have a user sign it, and then you can run that transaction on their behalf. The problem though is like whatever's in that batch call, like it has to be a single signature, and it's only for a single user, right? So Alice can sign a meta transaction with 3 different calls in there, and that's good. But if, for example, you have like Alice signs her own batch call and Bob signs his own batch call, we can't combine those two and run them at the same time. They still have to be separate transactions. And I guess so specifically the use case that I'm looking to do here is basically use meta transactions to close people's streams before they go insolvent. Now I have a little like hacky proof of concept that works already. So basically, like if Alice is streaming to Bob and she's an hour before insolvency, I can close that on her behalf as long as she's signed that transaction, which is great, right? But in the Sentinel, there's a single liquidation and then there's the batch liquidation, because sometimes people like to run 12,000 streams in parallel. So it seems like the best way to handle something like that, right, is if we could have a signature and the call, and then we could just batch all that together. And I don't think Biconomy would be able to just support that out of the box, right? Because they verify one signature and then they run the transaction, right? Whatever call data you have encoded there. So right now, really the only way to do that, right, is have your own contract, have this huge loop. So you're like looping and then calling Biconomy that calls Superfluid and does all this other stuff. So I guess what I'm getting at is like, if there is some, I don't know if there is any like interest or bandwidth for this kind of thing for Superfluid to do something like this, but having something more tailored to what Superfluid batch calls can do, I think would be really, really helpful, right? Like if we could do something like multiple signers, you know, and I can just batch it at the same time, like that'd be great for people that are relaying these meta transactions.
Yeah, that 2 things you mentioned here. One is adding a new batch call action, which is support to the 2260, which was a standard that supported the, you know what I'm talking about, the Biconomy one, that the forwarder standard.
Forwarder standard. Hold on. I've seen so many EIPs in the last week. I can't even remember what numbers are what. 1 second.
Sorry.
Yeah, just add a batch call action, which is a batch call. So you can nest them.
Nested batch call. Oh my God.
2771, I think.
No, it's 2770. Yes, I'm not sure. So that's actually has been talked about. But unfortunately, it's been no activity. So I'm not really pushed for it. That's what actually most of the standard are based off. Wait, sorry, am I on the wrong one? Sorry.
I think that's it. It's because
Maybe-
they mentioned running EIP 712 signatures on it.
In my browser history, I have 2771.
2771. Okay. Yeah, that's the one. Yeah, you're right. Yeah, so that so we're thinking on supporting a new batch call option of this, so where you can encode the message sender as a sender, or calling the batch call, then, you know, as long as the target contract support message sender. So that's one thing. The other specific use case you're talking about is being able to close a stream on behalf of somebody else is access control thing that we're doing fairly soon. So that allows on behalf of the user, like approval for the stream, right? There are certain design aspects we haven't finalized yet. I would definitely love your guys' involvement in that discussion. I will be outside product forum perhaps because a little bit hectic to record that live, but we'll just do outside protocol forum to have some design sessions and come up with the access control, right? So that's also coming up. The problem of simply storing the signature, especially the one with nonce, is that it's usually generally not a good idea, right? So first, the signature should be in general have expiration date. Secondly, the nonce could be invalidated if there's something happening in between. So that's in generally not a good idea, but we have something that we can offer from Supertoken level to be able to support those in a more straightforward way, I hope. Yeah.
If I may comment, I think that actually the base protocol itself should also allow transactions to expire, have some kind of expiry date.
Yeah, I don't know if I showed last time, or in other context. Is to
Thinking out loud here, but not sure this is possible. But so the idea is that you want to be able to have many meta transactions, but the issue is you need having to validate ON signatures. What if you change the kind of the signature schema to do something like is it the BLS schema, where you have basically you have one signature which signs many signatures and you only need to validate the one signature. So you change the signature scheme. I'm not sure. Is this something?
Yeah, so that's a good point, and that's another session we could do if we have unlimited time. But it's about typed signature. And what you're talking about, the way I thought about is it's kind of composable signature, right? So currently, when you sign a signature, it's always about one action, and when you sign another action, it's another action. You cannot compose it, and you have to sign 10 of them and batch them, right? Batch is just one thing. But signing signature still 10 times. So we don't have a standard currently in the ecosystem that is a composable signature. And 712 is the one that I would say has a potential to become composable. But that requires you to be able to decompose the action to be able to stack together. So you only need to sign one action, one signature as user, but the action inside is actually composed of various actions you actually care. So you can sign one signature for 2 actions, or sign one signature for 10 actions, but that's a composability. I never see that the implementation yet, but if we have plenty of time just to design things, I think we can come up with design. And Supertoken is a playground for new design, so why not, right?
But Meow, what you have in mind, would this also allow to consume only part of the actions in one on-chain transaction?
I would say so, unless that implies some security issue. But on the surface, yes, you sign a signature that has composable action inside, but you only selectively execute some of them, right? So as a user, you only say, okay, I won't allow 100 possible actions, just execute them on behalf of me, just go. Don't ask me to sign 100 times, right? So that's the kind of use case. I would love like more people work on more this kind of thing in the standard space. Less yield farming, less potato farming.
So basically, similar to what the operator pattern in 777
but much more
is
secure.
for, but on signature basis.
Oh yeah, I mean, not comparable. I mean, operator is such a brute force way. I would say signature is much more trustworthy.
Well, brute force. I wouldn't
Isn't
say
this
so.
how these L2s work, like Arbitrum? How these message inboxes, they use this type of signature scheme, I'm pretty sure.
Yeah, don't they use like Merkle's or something?
Right.
No oracles. I mean,
No, Merkle.
the Merkle root.
Yeah. Isn't that how optimism works? Or not optimism, sorry.
No, it's I think we may talk about different things. What I was talking about was, I mean, this is like ZK rollups versus other rollups. ZK rollups, you just have you need to validate a single proof. But if with all these optimistic rollups, the issue is of having n signatures. So you can still speed this up by just only validating one signature, which is signature over all of these. That's at least kind of what I was talking about.
I guess I'm not familiar. I can't comment too much.
Okay.
but I see why you see similarity there. But let me clarify what I meant, right? So this is a
Yeah.
712 signature, right? So apart from its own value of being able to see what you're signing, what you can think of generalize is that you're signing an array of actions, right? So if you standardize that, you're signing an array of actions, and each action item in the array is the one that can be handled by a separate function. And that function, you need to understand that you are receiving an array, and you only care about one of the items of the array. And that's the general idea of this composable one signature action, one signature pattern. I don't see anyone pushing for this. And besides the 712, it's not that popular either at the moment. I see a lot of values. I've been thinking about it, but
Well, the 712 is relatively popular, I would say.
That's true, actually, because when I used what's DXDY, they extensively used it. I actually knew what I was signing.
Yeah.
Is this
Economy does that too. Sorry.
Yeah.
I think this is the sign in with Ethereum kind of new feature thing. Is this ERC 721? No, not 721, I mean, but 712, is it? Yeah.
It's been
I think so.
at least 3 years, right? So the support is a prevalence, but
They just...
Excuse me?
Oh, no, no, keep going, yeah, sorry.
So there are different versions of it, like MetaMask so the EVM sign time to data. So there are several versions, like V1, V2, V3, V4, right? That's how the EVM level core is different. And the wallet support is a key thing here. I mean, MetaMask is the most supported, I guess. And it doesn't matter really, because if the hardware wallet doesn't support, it will just if you use hardware wallet through the MetaMask, then you're basically signing hardware wallet with a hexadecimal that you can't read. Anyway, you can't read structured data on hardware wallet, right? So you trust MetaMask that show you the right structured data, and trust MetaMask to translate those correctly to hexadecimals and send to your hardware wallet. That's a trust assumption, but still pretty good from user perspective. And make it composable is what I think could address some of the things we just talked about here, mentioned by Joshua. Something worth thinking. I mean, if you have interest in this, I mean, I think Tony, you were in the business of signing a lot of signatures. You might be interested, right?
I think you're right. Okay.
All right, guys, I got to jump, but yeah, thanks for chatting today, guys. I really appreciate the insight. Yeah, it's good chat, guys. And in 2 weeks, we're gonna philosophize in some of the superfluid stuff. Yeah, see you in 2 weeks about it. But yeah,
Good presentation, Didi. Thanks for doing the research.
Thanks, Didi. Yes.
Thank you.
Great stuff.
Cheers.
Great historian. Yeah. Bye-bye.
Bye.
Bye.